Hi everyone, this is Mr. Broyles from Silver High School, and today I'm going to be looking at starting the unit on forces. So some of the standards we're going to be covering today are the SEP using mathematics and computational thinking, that's the science and engineering practice, and then the CCC, the cross-cutting concept of cause and effect. So in this video today, what I want you to be able to do when we are done is describe what causes a force. State the elementary forces and provide examples, and describe the units of force and convert between them. Tomorrow, or in the next video, we're going to be talking about deciding if force is a vector quantity or a scalar quantity, and describing why that is, list the types of forces and describe their uses, and then we're going to learn to calculate weight. So the first thing I want to talk about is what causes a force. Well, what causes a force is simply a push or a pull on an object. Anything that changes the force or the object's motion. If it causes it to move, then a force was placed on it. If it causes it to speed up, if it causes it to slow down, if it causes it to move to the left, to the right, up, down, those are all things that are caused by forces. Now, there are four elementary forces that we talk about. There is gravity, the electromagnetic force, the weak nuclear force, and the strong nuclear force. Gravity is the interaction between two objects that have mass. The electromagnetic force is the attraction between the positive and negative charges or poles of an object. The weak nuclear force is the force that breaks a neutron into a proton, a beta particle or an electron, and an antineutrino. The strong nuclear force is the force that holds a nucleus together. Now, each of these forces acts over a different range, over a different distance, and it has a different strength. Now, the reach is the greatest for the weakest force, because it doesn't have to meet all these criteria. It acts over long distances, and that is gravity. So gravity has the longest reach, and that is simply because it looks at the masses of two objects, and you can calculate how far they're going to move towards each other. The electromagnetic force has the next longest reach, and because then we're looking at the attraction of opposite charges or poles, or the repulsion of like charges or poles, and that only acts over a fairly short distance. The weak nuclear force, that's the force that breaks a neutron into a proton, a beta particle, or an electron, and an antineutrino. Basically, this is what happens in nuclear reactions. And this happens over a very small, and the weak nuclear force is over a very small distance. Basically, the diameter of a neutron is what this force acts over. And then the strong nuclear force. The strong nuclear force has the shortest reach. It's very, very short. We're talking in the nanometer range. That's 10 to the negative 9th meters. That means you take this meter stick and you take its smallest units, the millimeter, and you're going to divide that 1,000,000 times, and that's how far the nuclear force works. And the nuclear force holds the nucleus together, because if you remember right, in electromagnetic forces, like charges repel each other. So how does a nucleus stay together? Because you have a bunch of positive charges in the nucleus. So the strong nuclear force is what holds those positive charges together. Now, when we talk about strength, well, the strength increases as the distance decreases. So gravity doesn't have very high strength, but it has an enormous reach. The electromagnetic force has a little more strength, and it doesn't reach out as far. The weak nuclear force is pretty strong, and because it holds that neutron together, but it acts over a very, very tiny range. And then the strong nuclear force holds the protons together. It's kind of a glue that holds the protons together, and that is what and that is an even smaller distance than the weak nuclear force and an even stronger attraction. Now, we're going to talk about units of force now. So there are two main units of force that we use. We use the Newton, that's the SI unit, and we use pounds. That's the unit we're used to using, and that is the empirical measurement. So, first of all, what is a Newton? Well, the Newton is the force needed to change the speed of an object 1 meter per second in 1 second. And the units for that are kilograms times meters divided by second squared. Basically, it's mass times acceleration. And then for pounds, well, I'm not going to tell you what the definition of a pound is because I'm not really sure that anybody really knows what it is anymore. But I do know that 1 pound is 4.448 newtons. And I can use that to make some calculations. So and I'm going to show you my document camera now. And if I use my document camera, I can look at this problem. So, and of course my pen takes now. So a car weighs 2,500 pounds. LBS is pounds. I know it doesn't make any sense, but that's what we have for it, LBS. And so I've got the weight of my car. What is the weight of the car in newtons? All right, so here's what I'm going to do. And I'm going to set this up as a T. All right? So I've got my T. I write what I know, 2,500 pounds, in the upper left-hand box. Then what I'm going to do is I'm going to say that 1 pound is 4.448 newtons. So then I'm going to take my handy-dandy calculator, and I'm going to say 2,500 times 4.448, and that is 11,120 newtons. And then I circle my answer because that's my answer. So I've got my answer here, and what I do is everything that's on top I multiply by, everything on the bottom gets divided by. So 2,500 times 4.448 divided by 1. Now I didn't put divided by 1 in my calculator because I know that anything divided by 1 is what that number started out to be. So this is the end of this recording, and I will see you in the next video. Have a good day.